Okay, let's just go back. I like to use different colors for headings because it helps me organize my thinking. So we are currently on 7.3, and we've done names to formulas. So now we're over here, and we're going to formulas to names.
Hi now. Sorry, I had to. The recording? You know the recording?
Oh. Who'd you say hello to?
Huh?
All the girls?
Yeah.
You know, it's really funny. When we did that the other day,
Yeah.
I had a flashback to when I was in grade 12.
Yeah.
We used to have announcements going over the PA system, right? And there was a guy in the grade 8 class that his last name was actually Casanova, an Italian kid. Do you guys understand the term Casanova? It's sort of like a lady killer. It's like a womanizer, right? Anyways, my friend, who was actually the school president, on St. Valentine's Day, the last announcement he says was, Robert Casanova would like to wish all the grade 8 girls a happy Valentine's Day. You could hear through the walls the laughter all the way up and down the whole hall. It was hilarious. It was hilarious. Poor kid, because the reality was this kid was really, really shy. Like he was like super shy, and so it was fun for us. For us guys, that was hilarious. Okay, so what I'm going to do is I'm going to try as much as I can to use the colors that we've used on the periodic table when we talk about these things here. Okay, so I'm going to do it this way. When we're named for the first part, we're going to name the ionic compounds, and again, these are the ionic compounds that have only one combined capacity. Okay? Then we're going to change colors, and we're going to use it for the multivalent, or the ones that are the pink. Okay? So let me see if I can get this right. So this is the rule for naming ionic compounds with one combined capacity. So the first word is always the metal name. Then you do the non-metal root, and then I have to change this up somehow, and then you're going to do add a suffix IDE. Okay, so that's the rule. So in this case, as two examples, if I have NaCl, okay, then I'm going to name it. This is the metal, because I have it on my periodic table. This is the metal. Okay, so this is going to be sodium. The non-metal, because I got my periodic table, I find chlorine, and so it's going to be chlor. That is the root. Generally speaking, the root, to find the root, you drop off the last syllable. In this case, ene. You drop it, and then you add IDE. So that's where we get sodium chloride. If I had KBr, if I've given KBr, this is a metal. I can find it way over here. So that is the metal. So it's going to be potassium. I find bromine, which is way over here. I recognize that it is a non-metal, so I'm going to drop the last ene, and it's going to be brom, and then I add IDE. So over here,
You'd add 8 or 9.
Name those. Right now, name them.
Strontium to nitrogen.
Strontium nitride and? Very good. Notice that in this situation, these numbers here do not come to play. It's got nothing to do with the numbers. Okay? So very good. You guys are on it. Okay. When you are dealing with elements with more than one combining capacity, that is all of these pink ones, things get a little bit more complex. So for example, if you were given PBI, I4, you'll notice as soon as you see PB, you look here and you say, well, wait a minute, I'm pretty sure that lead has got more than one combined capacity. It's in the pink, so it does. So now you have to say which one it is. So in this situation, if you were just given this and you looked at it, you'd say, my goodness, which one is it? Because I have to, in my name, I have to tell which one it is. What you know is that iodine is always -1. So this is always -1. 4 times, are you paying attention to this one? Sure. Four times -1, by 4 times -1 is -4 total. That, and I've only got one lead atom. That means that this has got to be +4, because together they have to equal 0. Okay? So when I look at this, I have to ascertain the combining capacity of the lead. And in this case, this is +4. Now, when you write this out, you are going to follow all the rules except this one addition. You have to include which combining capacity it is. Okay? So, lead iode, that's the same. What is different is that there. Okay, it's in the way, sorry. Is this here. You have to include that. For example, like if, suppose, the other option you would have, for example, you could have been given this, PbI2. Okay? Well, if you saw this, you would say, okay, well, I know that I is always -1, so 2 times -1 is -2. I've only got one of these, so that means it's +2. So when I name this is going to be lead to iodide. Now, why do we go through all this hassle? Well, because lead 4 iodide is not the same thing as lead 2 iodide. They're two totally different chemicals. They have different properties. they have different reactivities, probably have somewhat similar colors, but even that is not certain. Okay, so it's very, very important that you do this. Okay, let's have one that, here's one that is really common. If you look up here, way up here, Fe2O3. So again, you look at your periodic table, you find that iron has got more than one combined capacity. So that means that this is a multivalent ion. This means that I have to provide the appropriate Roman numerals. What do I know about this? Well, I know that oxygen is always -2. So 3 times -2 is -6. That means that this total has to equal +6. In order for that to happen, the combining capacity has to be +3. 2 times +3 is +6, and so that's a neutral. So the combining capacity of this +3, this has to show up in the name. So this is iron 3 oxide. Okay, do this. In the margin here, I'm going to just scooch over. Let's do a couple of them quickly. What about if we had one more? Let's see now. There's one for you. Min. Sorry. Two minutes. Should be able to do it before 2. In this case, that's because 4 is always -1. So 3 times -1. Take one of all those. Positive, right? You go into your periodic table, and you'll see that it only ever has.
Periodic table
That means that in order for that's a hard question.
Okay.
Damn it.
This is so loud. This is iron. Oh my gosh, I don't know anything.
I love you, Winnie, so much.
What? You probably did it right. I don't know what I'm doing.
Yeah.
Well, these ones are both charges, right? Yeah. What is it? I don't know. What are you talking about? Which charge is it? It's the 3. That's
I love you, Naya, so much.
That's fine. I'll do it. Kids are here.
Nickel. Nickel, not chloride. Nitride. No, oh, yeah. It's
Okay.
nitride. And that's nickel.
Yeah, he's a
There's something
I don't do
interesting.
stuff. I don't do science. I like history.
Where is it?
Nitride.
It is? Okay, I've just never heard that term before.
Well, it's not common because we use nitrates and nitrites.
Iron 3.
Okay, ladies and gentlemen,
Is it F?
let's just look at rationale for a minute here.
Because he has some.
One and the 3.
Let's look at the first one, FeCl3. Okay, if you saw this, FeCl3, there are 2 ways that you can think about this. The first way is the cheap, dirty, and to the throat one, and that's just the strategy from the strategy. Strategy is this, is that as soon as you see that Fe, you know on your periodic table that it's got more than one combined capacity. So what that is, that's a red flag saying that in my name, I have to have the Roman numeral. Okay, that's the first flag that should go up. Second thing is that at this level, you have to know that. Otherwise, you can't do this problem. And you always will be given information. Whenever you look at the periodic table, you will see that the chloride ion is always a -1. It's always -1. This 3 tells me I've got 3 of these. Okay? So let's draw a picture. You know that you've got 1 iron. Got 1 iron. But you've got 3 of these. Okay? You got 3 of them. But you know that these attach to here. Right? So how many hooks does this Fe have to have? 3. So he's got. So they're all attached. If he has got 3 hooks, that means that his combined capacity is +3. Okay? That's it. So when you talk about the name, it's going to be iron chloride because that part of the rule does not change. What does change is that there is more than one possible iron chloride. You have to tell me it's this one, the one with this combined capacity. So that's what I put there. Okay, now that's the rationale. Now, beloved, if it takes drawing pictures, then draw the pictures. Okay? In fact, it's probably to your advantage to draw the pictures because The reality is that in chemistry, that if you don't develop a picture in your mind of what's going on, you are going to be at the mercy of trying to memorize strategies that are mindless to you. You forget mindless strategies. Okay? The next one, COCl2, as soon as you see that, you look at cobalt and you say, oh my goodness, it's in the pink, it's got more than one combined capacity. But again, Cl2, you know that chlorine has always got -1 for combined capacity. So if you want to do the cheat, then 2 times -1 implies that that has got to be +2. If that doesn't work for you, draw it out. You've got 2 chlorides, each one with a hook. You've got 1 cobalt. Oops. 1 cobalt. For this to work, 2 hooks. That means that this is a combined capacity of +2. Therefore, cobalt to chloride. That's it. I threw the last one at you. Ni is what? Nickel, very good. N is what? Nitrogen. So when you look at nickel again is one of those multivalents. It's got more than one combined capacity. That's what the term multivalent means, more than one combined capacity. So you know you've got 1 nickel. Got 1 nickel. If I look at nitrogen, what I see is nitrogen has a combined capacity of -3. So in other words, it's got 3 hooks. If this is 1-to-1, 1 nickel to 1 nitrogen, how many hooks does this guy have? 3. That means that this guy has a combined capacity of +3. So, how do you name this?
Nickel 3 nitride.
Keep going.
Nickel
Okay,
3.
very good. Nickel 3 nitride. Nitride. Okay? That's it.
Wait, does that mean it's a solid?
It will be a solid. Yeah. It's an ionic. So it's a solid. If you throw this in water, though, it'll dissociate. It'll ionize. Yeah, dissolve. Yeah.
Oh, okay.
Yeah. Yeah.
Because nitride, because what I can tell, they usually invest
Okay.
like centimeters.
Okay. Okay, now what I want to do is I want to leave that domain and I want to look at the last and probably the snap. Oh, we've already covered the one last one. Okay, you guys are ready for this, I can tell. Okay. This is sort of like going to the throat now. Okay, as soon as you see a formula, you listening? Because this is the key. It's going to help save your sanity. If you look at a formula and it has got 3 or more capital letters in it, you know that this contains a polyatomic ion. Now it turns out that probably 9 times out of 10, maybe even higher than that, 9 times out of 10, the polyatomic ion is going to be the last group of atoms. So if that's the case, then what you have to do is you have to find your polyatomic ion sheet. And you're going to look on there to see if you can find PO4, which is there. It always has a combined capacity of -3. So you follow exactly the same rules. You don't change anything. The only thing that you've changed is that now you're dealing with a polyatomic ion instead of a binary. So what you do is you follow the same rules. You go like this, and you say, I know that I have got 1 total. Remember, say, boys in the hood, you deal with the whole ion as if they were 1 person. So this entire thing, PO4, has a combined capacity of -3, and you've got only 1 of these. So if you want to think of it this way, I've got a PO4, and watch this. I'm going to deal with it like it's 1. So PO4, and it has got 3 hooks. Okay? Fe, there's only 1 of these. So what has to be true in order for this to happen? It has to have 3 hooks. So, what's the name of this thing? Keep going. Iron 3?
Phosphate.
Very good. Iron 3 phosphate. Excellent. Iron phosphate. Okay? So the moral of the story here is when you deal with polyatomic ions, you use them the same way as you would just one of these what do you call them, non-metals. It's all the same. Same rules, same everything. Okay? Any questions on that? Okay. Now I want to, as I was saying, now I want to leave that domain and I want to go into the last domain, which is, in my mind, it's probably the easiest domain, and it's kind of nice that they leave it to the end. Now it turns out that when you're, we got to pull this out. Remember that covalent compounds, these are dealing with when you've got 2 nonmetals, okay? So nonmetal and a nonmetal. This is the only time this works. Nonmetal, nonmetal. Okay? So here is the rules. Going from a formula to the name, so you want to find a name, the prefix, and I'm going to give you the prefixes in a minute. This is a numerical prefix, the more metallic name. So in other words, we're dealing with guys that live in this neighborhood. These are all nonmetals. Remember, this arrow tells you who is more metallic and who is less metallic. So the more metallic name, the next prefix, numerical prefix, the less metallic root in IDE. Okay? So I'm going to have to figure out a way of doing this. the more metallic name, and I'm going to underline this because this is less metallic, root, prefix, IDE has got to be yellow, so I'm running out of color. I know what I'm going to do. I'm going to make purple. So prefix, I'm going to use the prefix, more metallic name, prefix, less metallic root. Sorry, oh, that pretty much blacks it out, doesn't it? And then IDE. Okay? Let's talk about the prefixes first. This is these words are all based in I'm not sure now. It's either Latin or Greek. I can't remember. Anyway, these are the prefixes. Where's my pen? There it is. For the number of atoms being 1, the prefix is mono. Mono, like mononucleosis. Mono means 1. 2, if there's 2 atoms, it is di. If it's 3 atoms, it's tri. If it's 4, this is where it gets a little bit, I think this is Greek. Tetra. Greek. I think these are based in Greek words. Tetra. 5 is penta. Penta, like as pentax. 6 is hexa. 7 is hepta. 8 is octo. That's exactly where it comes from. Okay? Now 9 is it, I think it's nona? Is it nona? Nona. And the last one is deca. Okay? Now this is the rule. This is the rule that you follow when you're dealing with non-metals, okay? There is one glitch though. You can see at the bottom here. Here's the glitch. And you need to write this out. If the first atom is only 1, you drop the mono. Okay? Yes.
What does it say after first?
Atom.
Oh, okay.
If the first I should probably said first element you only have 1 atom, then you drop that. And I'll show you why. Okay, for example, if you have if this was here, if you saw this guy here, you would look at your periodic table and say, oh my goodness, both of these guys live in non-metal land. And you say, oh, okay. So there's 1 here, 1 carbon, 1 oxygen. So technically, if you were to follow this rule at the top, this is what you'd write. You would write mono carbon monoxide. This is what, strictly speaking, what you would write. But the glitch, the one weird rule, is that if this is 1, you drop this guy. So this becomes carbon monoxide. And you guys probably have all heard of carbon monoxide. It kills people. It kills people because hemoglobin would rather pick up carbon monoxide than oxygen. It preferentially binds to carbon monoxide. Okay? So, here we have, on the next page, we have this. I've separated it out, but this would be CCl4. Okay? I want you right now, chat among yourselves, share, pair share. What do you think the name of this compound is? What do you think it's this? Why do you think that is? Anybody want to shout out what that bad boy is? Very good. This is carbon tetrachloride. Carbon tetrachloride is an organic solvent that is used a lot in organic chemistry labs. We use it to dissolve nasties, and it itself is nasty. I believe it is carcinogenic. Okay. Next step up. N2O3. Do it. As soon as you get it, yell it out. Well, don't yell it out, but loud enough that we can all hear it.
What was the first one again?
Carbon tetrachloride.
Carbon tetrachloride. See, you said the answer, right? I yelled no.
Chloride.
We're working on this here. But there is such thing as carbon tetrachloride. There's also such thing as carbon tetrachloride. Yeah, all very nasty. All very nasty. Yeah.
We have nitrous oxide.
Oh, yeah.
It just might be.
Did
Tom.
you miss anything?
Is it trinitrous oxide?
No, you didn't.
No.
Why are you mad?
No, trinitrous dioxide.
You've got your prefixes switched.
Dinitrous trioxide.
Not nitrous.
Nitrous.
Dinitrogen, because it's the name. It's not a root. That's right. Okay, did you guys get that? Dinitrogen trioxide. Okay? Now I want you to change this. Put sulfur trioxide into symbols. Why did that be in symbols? It's so quick, yes.
Don't you dare. Don't you dare. They see it. No, don't have that. Well, you said this was not important, so. Ooh, no, it's not. You put it in the staple. It's so wonky. You never had like. I'm touching my hands.
Yeah?
Is oxygen outside?
Yeah. The root for oxygen is just OX, ox. Generally speaking, the root is found by dropping the last syllable, but it's not always true. It's another governing rule is how does it sound? Is it bumpy or is it smooth? Chloride. Yeah. Okay. Next, dead end link. Yeah. 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 There's a link. You see the link there. I don't know if you can find it another way, but I'm thinking about 10 years ago, there was this big scare that was going around. The dangers of dihydrogen monoxide, and it was making claims like ingesting this can cause death and all sorts of things. And it was a big spoof. People were getting really bent out of shape on this. They were like really going crazy. But you guys, now that you know how to go from names to formulas, you'll recognize that this is just dinitrogen monoxide. And it was really funny because it was like one of those scares that was like, oh my goodness, it's in all of our food. It's taking over the world. Nobody is paying attention to this thing. We are so dead. We are so dead. And yet, the people that could understand was that this is funny. This is hilarious. Here is if you go on Google Images, the link that is up there is dead now. But if you go on Google Images, you'll see ban dihydrogen monoxide. So it says what is it saying here? The dangers, the uses, and the places you'll find it. Okay, so it was a big deal. It's hilarious though. I thought it was a chuckle and a half. Okay, there's one more on the bottom there. Nitrogen trihydride.
Oh, no,
I want
that
you
was
to
right.
do that right now. Nitrogen trihydride, that's an easy one, right?
Because it doesn't want to be carrying.
I'm giving you guys out.
pass it to
This
you.
is, I don't know how far we're going to get through this today, but this is, if you have trouble, isn't that right?
Binary. Yes. Ionic. Binary ionic problem.
That's why it's so funny. Okay, ladies and gentlemen, this is an assist that I am going to actually, don't tell anybody outside of this classroom, but I'm actually going to allow you to take this into your chapter test. Okay.
Are we allowed to write notes on the paper?
I'm going to lead you in through this, okay? So I am going to be using this is going to be matched to this and this. Before we start, if you do have something orange, my suggestion is, and this is what I'm going to do, I'm going to just outline this whole thing in orange.
I'm gonna highlight yellow.
I definitely need to get a new orange highlight. This is not going well. Okay, so what this paper is this is a synopsis of everything that we've done in this chapter on one page. Okay? So, just as an overview, we're going to talk about binary ionics. Binary means two. So, for example, a metal and a nonmetal is binary. Two nonmetals are binary, okay? And the other option is polyatomic. So the first version is binary ionic, but that is not multivalent. So this one here, I'm going to color, and it's going to be ionic. So I'm going to color it this way. Just a binary, this side, this half. This part is green. This part is blue, because we're going to be dealing, the green indicates the metals that have a single combining capacity matched with the blue guys, which are the non-metals, okay? So here is this is where you have a metal and a non-metal. The rule is metal name, non-metal root, and then IDE. So in every case, the top cases I'm going from a formula to a name, and then down here I'm going to go from a name to a formula. So this is sort of like a template that you can use. Okay? So, with periodic tables by your side, you can see that this is K is potassium. So that is the metal name. The non-metal root is sulf, because it's sulfur, and you're going to drop the last, you're going to drop the last syllable, and so this is going to be sulf. And so then you're going to have, I put a dot just a separator, IDE. So that's sulfide. Okay? Going, okay, I'll wait for a second so you guys catch up, because the second part, there's a little bit more to it. So the second part, you're going from name to formula, so scandium carbide, so this is where it helps. Scandium is SC, so SC, and you're going to follow the rule that you put the two symbols and you put the combining capacity. So I go to my periodic table, I find scandium is right there, combined capacity is 3, so this is plus 3. Carbon, so the symbol is going to be a capital C, and carbon is 4. So now I'm just going to do the cheat. I'm going to do that in red so it draws my attention to what do I do now. So this is going to go here, and this is going to go there. So my answer is going to be, this is going to become SC4C3. Okay? Okay, now I am going to look at the other version of binary ionic. That is where the element has more than one combined capacity, and those guys are in pink. So I'm going to color or highlight this half here with pink, because that's how I did it on my periodic table, and then this part in blue again. So here we go.
Stop. Stop.
Sorry.
Okay? So, the rules are the same. The only difference is that you've got to somehow incorporate the combining capacity in the name. So here we go. Actually, I think we've already done this one already. So this is between a metal and a non-metal. The rule is metal name. Then the combining capacity, which we have to figure out still, we don't know what it is. The non-metal root, and then IDE. Okay? IDE. I look at my periodic table. I find cobalt. Cobalt is living in the pink zone. So now I know what I've got to do. I look at cobalt. I'm going to scooch in a little bit more. That's what I'm doing. Cobalt. I know that F is always -1. So 2 times -1 is -2. 2 times -1 is -2. There's only one of these, so that means that this guy has to be +2. 2. And this plus 2, I'm just going to do a little bit of highlight here. This plus 2, that is the combined capacity that's going to go there. Excuse me.
Here,
Thank
I'll
you.
make it so I see you.
I've got to be careful. I've got to save some brains for next week. So this is going to be metal name, cobalt,
Oh wait, no, he's just writing. I'm just gonna write it down.
2, fluoride.
We can't see.
Thank you. So the cobalt, the 2, and the fluoride. The fluor, and then IDE. So yep, certainly. Okay. Next one. Polyatomic ions. So this is where instead of using a metal, a non-metal as your cation or your anion, it's going to be a polyatomic ion. So remember at the beginning I color-coded this orange. So what I'm going to do is that we're going to start again with the green. It's the green guys. So this is the greens. And with polyions.
Not my fault. It is.
Do you need a respiratory specialist? Yes or no? Yes or no? Yes or no?
Respiratory. I need one. Anybody got a
What's
respiratory?
respiratory?
Breathing.
Oh, so like if you breathe weird?
Okay, let's rock this. So the rule is this. This is between a metal and a. Okay. Oh. Big mistake. Big mistake. It's not between that and a non-metal.
Oh, right here, I can still highlight.
This is a polyion. I gotta change that. What am I doing? What am I doing? What am I doing? What am I doing? Okay, here we go. And a it's gonna smudge it. It's gonna smudge it. I know it's gonna smudge it. So the rule is this. This is really simple. It's just the metal name and the polyion name. In some ways, it's the simplest naming there is. And so again, how do you know if you are dealing with a polyion? You count the number of capital letters. So here we have 3, so we know that we're dealing with a polyion. In this case, the polyion is in fact the last 2, and you can tell again, you have confirmation because it's actually bracketed. Okay? It's bracketed. So, rule, metal name, polyion name. Metal name is strontium. Can you see now why I pushed you guys a little bit to know your symbols? Because otherwise, this process that we're doing right now takes forever. Because then you have to find what's SR, or what is that? And you're looking over the whole thing, and you wasted 5 minutes. Metal name, polyion name, NO3, I go here, NO3 is there, nitrate. So this is strontium nitrate. Just that simple. Just that simple. Now, going the other direction is a little bit more of a challenge. Okay? The reason for the challenge is that you have to figure out how many phosphates and how many calciums you have. So you follow the same rules as you did up here, where you put down the combining capacities and then you cheat. Okay? So that's what I'm going to do here. Calcium is +2. Phosphate is PO4, but its combined capacity, according to my magic list here, is always -3. So what am I going to do? I'm going to cheat. I'm going to take this, put it down here, and I'm going to take that, and I put it down here. Now here's the rub. This is a little bit complicated. Guys, pay attention. You got to pay attention because you're going to be lost. You guys are going to be making mistakes all day on this one. Remember I said that you have to deal with the PO4s or the polyions as if they're a single atom? This is where it comes to roost. I'm going to do this on the board just to make state my case. If I did this, this would become Ca3. Remember I said you have to treat these guys as if they're one? How do I put the 2 down here and still treat it as a 1? You are on it. You are so on it. It's the same rationale. It's the same rationale as the hooks. You treat them as if this is 1. I have seen this many times, and I'll tell you the polyion that I see this the most with. If I said to you, if instead of calcium phosphate, if I said to you calcium hydroxide, calcium again is C+2. Hydroxide is OH -1. So you know what I see? All the time. All the time. They do the cheat. This becomes Ca, and they say that's fine, because it's a 1, and then you go like this. OH2. But thanks for playing. You can eliminate it in round 1. Because what you're telling me is that in this process, you have got 1 calcium, 1 oxygen, and 2 hydrogen. If I do it correctly, like this, what this tells me is that I've got a calcium, 2 oxygens, 2 hydrogens. If I was to try to draw this with hooks, this looks like this. It's got a calcium in the middle. It's got an oxygen here, hydrogen, oxygen, hydrogen. These are the hydroxides on the end. This is the calcium in the middle. Try drawing that. It's not the same thing. Not even remotely. So in this one here, I have to protect that. And Scott, you're wow, that's great. This becomes Ca3PO4 close bracket 2 calcium phosphate. Okay. We're going to continue with this next day. Don't go running away. I've still got you for do I have you for 1 minute or 6 minutes?
1 minute.
1 minute. I need you to take a peekaboo. Your homework package.
Oh. Homework. Oh.
Seriously, Scott, do you need a respiratory specialist? Yes or no? Yes or no? Do you have asthma?
Yeah,
Do you have
he has asthma.
Do you have bronchitis?
He has asthma. That's an excuse.
Settle down. Settle down. I need you to still get through this before I can let you go home. Listen up. I only have you for 2 days next week. Okay?
You?
Yeah. I only have you for 2 days next week. As far as I'm concerned, we have finished the chapter. We have not done the practice work that is necessary for you to do well in the chapter test, though. Okay? So, on Monday, the only thing that I have planned is to finish off these block sheets that we just started today. You should be looking at for Monday. There's what you guys know. I'll put it to you this way. You got a lot of work to do. Okay. Here's the thing. Really, next Thursday is the last day I'm going to have you before the spring break, which means that you're going to come back Thursday and say, I didn't know there was a chapter. I am so screwed, guys. I am so screwed. Okay? You guys really need to have a chapter test on Thursday, which means that between now and Thursday, we have a blackboard worksheet. Okay? There's a lot of work on the board here. There is a mistake. I have Monday, March 11th, and it's gone. It's Tuesday. So what we have to do is, if you have not done CYU 7.2, that is due today. So that's chapter 7.3, Ionic formulas of naming, CYU 7.3, CYU 7.4, and chapter 7.4, molecular formula writing and naming. That's a lot of work. What I'm referring to in those worksheets is this. 7.3, binary compounds. 7.4, molecular formula writing and naming. And there's a whole mess in 7.2 and 7.3. This is the way I'm going to run it. I will not deduct marks until Thursday. Can I say it to you this way though? If you don't do these and the and what's on the board, next week is going to be very ugly for you. Okay? So you've got a weekend. I know you're going to want to go skiing and stuff like that, and I hope you do. But somehow you are going to have to reschedule your busy lives to include some hardcore work. Welcome to Science 10. From here on, it does not slow down. Science 8, Science 9, Science 10. And it has been that way since I started working here. Problem is that most students think Science 8, Science 9, Science 10, and you're kidding yourself. Love you. You've got some work to do. If you are having problems, you owe it to yourself to come find me before school, lunchtime, or after school to get the necessary help. Okay? There is no excuse for you going into this saying, I didn't know how to do it. If you come to me and you say, if you get a bad mark and you didn't know how to do it and you didn't come to me, no tears. There's no tears. Go. Yes. I think there should be. You know what I'm going to do? Here, wait a minute. Oh, by the way, 7.4 is also a handout, so you don't have to reinvent the wheel.
Where's 7.3?
You guys should have all got that. You should have it. Oh. No, I'm going to print some extras off, but you should have it as part of the first initial handout. It came with the notes, not attached to the notes, but in addition to the notes.
Wait, can you give me a copper chloride, please? 1% more, right? C-U-T-E.
If anybody anybody does not have said handout,